Differential shock can also become a problem when elevated heat exchange equipment is drained with a substantial vertical drop ahead of the trap. Under normal conditions, condensate drains down the walls of the pipe. A sufficient volume of steam constantly flows down the center of the pipe to replace the steam that is condensed by radiation losses of the piping and the trap body itself. The steam flow rate increases if a thermostatic element such as the bellows or wafer in an F&T trap opens. If a slug of condensate seals off the pipe, steam collapses downstream of the seal. Again, a pressure differential forms, and this, along with gravity, accelerates the slug. When this piston strikes the trap, it can damage a float, the thermostatic element, or other parts of its mechanisms. To avoid differential shock arising from this situation, use an F&T trap and backvent it to the top of the vertical line to maintain near equal pressure throughout the riser, even if a slug of condensate forms. In both of the two previous cases, the condensing of steam downstream of the seal produced the acceleration. It follows that the likelihood of differential shock arising and causing water hammer is greater in uninsulated pipes, especially on outdoor systems, than in insulated pipes. Long runs of any kind between the heat exchange equipment and the trap can produce this situation and should be avoided. Damaging water hammer may also occur due to differential shock whenever there is an improperly dripped pocket ahead of a control valve. Condensate builds up in front of the valve while it is closed. When the valve is opened, the slug of condensate is driven through the valve and into the piping and equipment by the live steam. The placement of a riser and a drip trap immediately upstream of the control valve will prevent this rampaging slug. To control differential shock, you must prevent condensate seals from forming in biphase systems. Condensate lines must be sized correctly, and long vertical drops to the traps must be backvented. The length of the lines to traps should be minimized, and the lines may have to be insulated to reduce condensing. The installation of a proper drip leg ahead of control valves will prevent differential shock from occurring when the control valve is opened after a period of closure. Careful attention to these few guidelines will prevent most water hammer. Prevent the sudden stopping of water in pipelines by closing manual valves slowly and by installing spring-loaded, center-guided silent check valves where appropriate. Prevent thermal shock by using a sparging tube wherever flash steam is discharged into condensate at a lower temperature, and by ensuring that heat exchanger tubes are filled from one end. Prevent differential shock in biphase systems by providing return lines that are properly pitched and of adequate size. Avoid draining equipment with long lines to the trap and insulate condensate lines whenever necessary. Following these guidelines for the proper design and operation of your system will minimize the likelihood of the shocks that cause water hammer. This, in turn, will greatly reduce the likelihood of damage to your system, to your product, and to your personnel.